So you want us to try, okay, I remember you said let's do the rules first.
Yeah.
So number one is always push electrons towards the less electron rich element or toward a double bond. Again, I'm going to write this in the layman's language possible. We are
Okay.
when we are in the last leg of the class, so I have to be just clear.
Okay.
And then, so in your resonances, this one is very important. For example, it's asking you where the problem is. I'll show you one of these example. Uh, for example, J, that's a problem.
Okay.
Number two, you want to keep octet rule. Do not break it. I hope you remember what octet rule is.
Yeah, everything has to have 8 electrons.
Yeah. Then the best resonance, if you have multiple resonance structure, has negative charge on most electronegative element. Of course, the opposite, positive charge on least electronegative element. And then it should be having minimized charges.
Okay.
Now, if we have more, we're going to write them here. Let's start with the first one.
Okay.
I'm assuming these, yeah, these are positive charge. So if we look at A, I'll pause and wait on you. If we look at A based on the rules, they're pushing their arrow this way.
Okay.
Oh, the other thing I should have shown you are the three cases of the resonances. So you can have case A will always push two arrows. And then you can have case B will push one towards the plus sign. You know why? If the element is here, that's positively charged. And then you can have case, as long as you're maintaining octet, that is. You
Okay.
have case C where if this is X and Y, you're pushing it towards the more electronegative. Those are the most common resonance patterns. It's the other set of rules.
Okay. Um, I remember like it'll ask you to draw like all of the resonance structures. Is there like a way to know how many there are, or do you just like arrow push until?
No, no.
Okay.
You keep drawing until you're not repeating yourself anymore.
Okay. Um, I'm sorry. Can you explain C again?
Best resonance structure has negative charge on most electronegative. Yes, so if you have a carbon and oxygen, you want the negative charge on oxygen,
Okay.
and you want the positive on carbon.
Okay.
Yeah. So, for example, you want that negative there, you want the positive here. That's what this rule is trying to say.
Okay. And then can you do C from the elements that you did, like element A, like how the arrows are, like the different cases you can have? Is that what you said?
Say that again.
Like C at the top in blue.
Yeah.
Can you explain that one again?
Oh, that was the C you were saying.
Yeah.
So, if you have a carbonyl, you want to push towards the more electronegative element.
Okay.
Yeah. So again, oxygen will get negative, carbon will get positive. That C matches the C in red.
Okay. Okay. I'm ready to move on.
My dear, trust me, those are the rules I'm going to use.
Okay.
So now assume that I'm pushing A the way it's pushed. Let's see if it's even a thing. That will mean that where the double bond is leaving, we always put a plus charge.
Okay.
Today I'm babysitting you. I'm spoon feeding you, but it's okay because we want you to learn this, given that now
Okay.
your final is
A massive part of my grade.
it's
I'm scared.
wow, 33%. My finals are usually between 10 and 15. I usually keep them at 10%, not even 15.
Yeah, all my other ones are like max 15. 33 is.
That's massive. And I know why he's doing that. That sounds like a he, it's not a she. Is it a he?
It is a he.
Yeah, that's a he, not a she.
Okay.
Because
Funny.
men were very less attentive in details. He must have even forgotten what he said in the syllabus.
I think so, but also he was known to be the easy professor, and he's the hardest orgo professor this semester. So he I think people were mad that or he was mad that people were calling him easy. So he's no longer easy. But
So
I'm
it's your
happy.
fault.
Yeah. I'm happy he's not easy because I need this for the MCAT. So I'm lucky either way, but 33% of my
It
grade.
will help you in organic too, trust me.
Okay.
There's a benefit to it, only that there's a risk on your grade. Now tell me why red is wrong. Why the red resonance structure is wrong.
Octet rule. It violates the octet rule.
Octet rule is violated, and plus this charge is gonna be 2 plus. Let's do the Fermat charge. I gave you the formula for Fermat charges.
Okay.
Nitrogen is valency of 6. No, not 6.
I think it's
Nitrogen
5.
is 5. I'm tripping. I've done too much chemistry today. 5, and then there's no lone pair, and there are 5 lines.
Oh yeah.
So the Fermat charge is 0, really, not plus 2. So that one will trick you to think, hey, that's good. I've minimized the charges, as the rule says.
Mm-hmm.
But it's not good because the octet rule, which is a golden rule, has been violated.
Okay.
That's the reasoning.
Got it.
So no reason octet rule violated.
Okay.
I'm glad we have the rules besides us because we can always use that. And then for B, look at it. Is there any violation?
No.
Yeah, there's no violation.
We're just gonna get a negative charge on the oxygen. That's it. But that doesn't violate any rule, right?
No. But the best structure will be. This will be the best.
The one with the negative. Oh.
No, the one with minimal charges.
Okay.
Remember again, minimal charges, minimize charges.
Okay.
Best resonance structure has minimized charges. We'll see in red.
Okay.
However, we're going to say no violation. C. So the best way to see if there's a violation is to draw the result.
Okay.
So if you can draw the result, you should have used red. You will get this. But remember, there's a hydrogen here. Implied hydrogen. Plus charge goes to the back. The plus charge always goes where the double left.
Got it.
Tell me if it's okay or there's violation.
There's a violation, right? There's too many. It violates octet rule on this carbon, the central carbon.
Yeah.
OH bond is.
octet rule again because there are too many electrons here. Don't know if that's a spelling or this A, whatever it is. So this will not happen. I'm glad you're getting it. Or D. Yes, the arrow is going towards the electronegative element, but there's a problem. You tell me.
Um, it's the octet rule again, right?
Exactly. 1, 2, 3. Let's see. The lone pair is here. I'm doubting if we'll have that plus charge. Let me see. 4 more charge on oxygen. 6 minus 4 minus 2 weak. It's a negative.
Okay.
I know it's the wrong thing, but I just like to account for.
Everything.
Yeah. So
Okay.
again, here octet rule violated. Let's go to E. What do you think in your assessment?
Um, I think 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 6, 7, 8. I think it's fine.
It's not fine
Okay.
because if you're pushing it this way, you're forgetting about the implied hydrogen, which is why I keep showing you the implied hydrogen.
Okay.
Again, this will not happen because of the octet rule.
Got it. Okay.
Okay. And then I really want us to do all this because
Okay.
this will haunt you in
Okay.
organic too, in your exams, in
Yeah.
biochemistry, in MCAT, everywhere. This resonance thing is everywhere.
Can't wait.
Yeah, so so we're making a double bond here. There's 2 hydrogens here. We know that. So I'm still gonna show them. Again, that will tell me that my octet rule
It's violated.
is violated.
Okay.
Showing the implied hydrogens is quite helpful.
Got it. Okay. And then plus charge goes up there.
And G is a huge felony. I don't know what someone is thinking there. You don't just break a sigma bond.
Oh yeah, you can't do that.
You
I know
cannot
that.
do. Yeah,
That's a
it
big no-no.
maintains the octet, but still, that is like I shouldn't even include it in the rules. It's kind of obvious.
Yeah, I did know that. So
Okay.
what would you say for that? Like, can happen?
Never randomly, yeah, never randomly break.
Okay.
There should always be a push effect or a radical reaction, initiation, propagation, termination.
Got it. Okay.
That's not resonance.
Yeah.
Okay, that's a make-believe. Let's do here. It's the same issue on here. Same issue.
What the heck? Why would those are like such a waste? But I guess people will probably make that
Yeah. But
mistake.
by the time you see it included in the question, they know there are people who randomly do that, just break bonds for the sake of it. And then I, screen your 3 red rules. This is kind of case C in the blue. The one I showed you with the C double bond O.
Mm-hmm.
Yeah, it's similar to this. Tell me if there's a violation or not.
Okay. I would say no.
There's no violation because you are going to the more electronegative.
Okay. And then for this one, do we have to calculate formal charge?
Yes.
Okay.
So you'll have 2 lone pairs there. This one is 1 bond less. It's just gonna be a positive if you try. Fc of the carbon will be 4 minus no dots minus 3 lines. It's a plus 1.
Okay, that's why I put the positive charge on it. Okay.
Yeah, that's where the plus charge comes from. And then the nitrogen will be 5, I remember now. 4 dots, 2 lines, negative. Still, this would be,
The best one because there's
yeah,
minimum. Okay.
that's the most stable, most relevant. Minimized charges. No, let me do J here. J is interesting. Let me see what's going on there. What do you think about J? Look at it. Let me know.
Okay. Hold on. It violates octet rule because the nitrogen doesn't have a full octet, like the one close on the right side.
Say that again.
Oh wait, are we doing the same one?
We are doing J. Which one are we? Where are we on? Oh, I'm on K. That's K. Let me do J here. I labeled the wrong one. Are you on J?
Yeah, I did that one. Sorry.
No, it's my mistake. Okay, so
Oh wait, sorry. My professor did just say he's making a deviation from what is written in the syllabus. In the
he's
past, calculating for
he's making
grade.
what?
He said he's making a deviation from what is written in the syllabus. He said for grading, to make grading easier on his part, he's going to count it as 2 exams. But he said he wasn't going to send an email out, basically.
So you would have decided to do that without your knowledge, basically.
Yeah.
Oh well, so you really have to do well in the final. So that
Yeah.
if you do well, you have an advantage. The problem is most people will not do well, then it will be a disadvantage to many. I know syllabuses are subject to change, but this is
Yeah.
quite a big change.
Yeah, right? 33% of somebody's grade when it's meant to be, what,
Yeah,
15? That's
let's say
insane.
someone was hoping to just keep what they have already, and then they have not been studying as hard. That's a lot of catch-up.
Yeah, it's absolutely insane.
Yeah.
Well,
Well, what do you do? He has replied you.
all right. Well, let's go back to studying since
Yeah, yeah, yeah,
33%
yeah, yeah.
my grade.
Yeah.
I said it violates the octet rule for this one.
It does. Let's see. Does it? Oh yeah, it does because you are leaving that nitrogen.
Mm-hmm.
This nitrogen is octet. This one is octet. So after the resonance here, we are violating the octet. Yes.
Okay.
So that's not fine to do. Yeah,
Okay.
I agree. This is not octet anymore.
Okay. And then should we do K?
Yeah. So for K, only one arrow is pushed. This one goes to the first pattern. See how I told you if you have an element with a lone pair, you push two arrows?
Yeah.
So in that case, we are going to violate the octet because if we just do what is done there and stop there,
There's
we're
gonna be
in
a lot.
trouble.
Got it. Okay.
This guy has 10 electrons on that carbon, which is why we always want to do the second arrow.
Got it. Okay. So if I was just doing this myself, I would make sure to push it twice. And
Yeah,
then
yeah,
leave
yeah,
a
yeah, yeah,
positive
yeah.
charge on the oxygen, right? Yeah, because
Yeah,
it's for the lone pairs left. Okay.
exactly. So L, you know why L is wrong. We talked about that.
Yeah, because you can't make the double bond, right?
Yeah, the thing is violation of octet.
Okay. Got it.
Nitrogen gets a plus, carbon, I don't know what he will have. That carbon would be 4 minus 0 minus 5, that's -1. Anyway, this is not happening because of violation of octet.
Got it. Okay.
So now that you know these rules, the next set of questions will be easier to draw the resonance structures.
Um. So then, when it comes to like the next one was ranking the significance. That's just choosing which resonance structure is the best, right? So it's does it have a full octet? Are there minimized charges? Yeah,
Where
right?
does it ask us to do that?
Here I can
Oh, it's
screen share
another
again.
one?
Yeah.
Okay. Let me unshare. Oh, it's sharing anyway.
This one.
I was waiting for it to be clearer, the resolution.
Here, wait. I wonder if I move.
No, it's fine the way it is. I
Okay.
can now see it. Okay, now stop sharing. Let's see.
Okay.
Can you see my screen?
Yes.
Ranking the significance of resonance structures. Draw the resonance structures. Now we draw first and then we rank.
Okay. And then the rules are the same for ranking that we went over before.
Yes. Rule C in red applies. Now, I show that is allylic, which is pattern A in blue that we talked about. So where do I start my arrow?
On the double bond?
No,
What? Really?
no, because just look at the pattern A. Where is it? This one. You start from the lone pair.
Got it. Okay.
When you have a lone pair and a double bond, you start from the lone pair. If it's the double bond and a positive, you start from the double bond. If it's a lone pair and a double bond, start from the lone pair.
Okay.
Which is why I gave you these three patterns.
Got it.
Master them. Then you know how to decide where to start.
Okay. I will have them mastered. Don't worry.
Thank you.
Okay, so I would go towards the double bond, so I would move them.
You'll move them to this bond. But again, if you stop there, octet rule is defiled. So we have to open up the bond. Always you're moving 2 arrows in this case when you have a Lily clone pair.
Okay. And then when it comes to the arrow pushing, is it like, I guess like in a mechanism, like, so you know how I pushed that one arrow? For the next one, does the tail have to go where the last arrow ended?
No.
Okay.
In this case, it starts from the bond.
Okay. Got it.
What you're talking about is similar to what we are doing in radical reactions, but this is not radical. That's where we were starting 2 arrows on the same bond.
Okay.
Yeah, but here, nope. Exactly what you're doing is what you should be doing. If you start from the lone pair, make sure the arrow is starting from the lone pair, pointing the bond next door. And then start from the pi bond next door and open it. Let it end on the element adjacent to the double bond.
Okay. Got it.
Okay, so now we are left with one lone pair. We made a double bond right there.
So like,
The lone
how
pair.
do I know when to stop?
Huh?
Like, how do I know when to stop with resonance?
You will repeat yourself. I'll show you.
Okay.
We'll get to a point when if I keep doing it, it will take me back to the original.
Okay.
Nobody
So
knows.
that's when you go till?
Huh?
That's when you go till?
Yeah, that's how you tell that you are end. You have stopped. When you see that you are about to draw the original structure, you are done.
Okay.
So when you do this, do the formal charge, the oxygen will be positive. This carbon has no hydrogen. It will be negative. Now, at that point, you are in trouble, which is what you're asking me. If I try to do the resonance here, then I'll be forced to go this way because I cannot go forward. If I do that, see where I end up. I end up where I started. No need.
Okay.
So these are the only 2 ones that we are looking at.
Okay. And then the one that we started with is better because there's less.
Yeah, because of minimized charges.
And the octet rule.
Octet is maintained in both.
Oh, because we put that negative charge on the thing?
Yes.
Got it. Okay.
It's just the minimized charges.
Okay.
We are learning.
I was dreading going back to resonance, but it's not as bad as I remember.
Now, is this supposed to be a plus charge or a negative?
A plus.
A plus, okay. Now, this is supposed to be technically case C of the patterns of drawing resonance. Tell me where you'd start. You know how to draw. The rule I gave you was you always push your arrow towards the plus sign, towards the more electron positive element.
Okay. Yeah, so I would start on the lone pairs.
And you don't push to the plus, you push to the bond.
Okay. And then do I just stop there?
And that's it. We don't have another one.
Okay.
If you try to do it after this red one, it takes you back.
Okay.
Now, the oxygen is the only one that's gonna have a plus charge. There's an implied hydrogen there.
Okay.
Now you tell me which one is more stable. I gave you the rule number 1 in red. It's the one that should help you.
It's the first one because the plus charge has to be on the least electronegative atom, and then the if it was a minus charge on the oxygen, then it would be that one because you want the minus charge on the more electronegative atom, right?
How about the octet rule?
I hate the octet rule. I always forget it.
I'll tell you, in principle, we usually go with octet rule. In principle, we usually go with the octet rule, but for this one,
Is it
man.
violated? Is the octet violated? Like,
No, octet rule is affected, is followed. The oxygen has 8, the carbon has 8. The original one, the carbon has less octet. I'll lean more to, even though the oxygen has a plus charge, I'll lean more towards that. Because at least everything is octet.
okay.
See, now you have competing rules, but the octet should always be supreme, because if you have to draw the Lewis structure, you're going to draw the red. You will not draw the black one.
Okay. And the black one is wrong because the carbon with the plus sign on it, or the positive charge, that's what's violating the octet rule?
Yeah, that's not octet, it's a sextet.
Okay, got it. Okay.
I'm assuming we have what, a negative charge down here or a plus charge? Which is which?
That's a plus again.
Okay, you will tell me where we should go. This is pattern B in blue, where we started. Let me bring it up.
So move the double bond towards the positive charge.
Yeah. Oh, this is the student I had before you. Let me see, where is it? This one. Yes, pattern B here. Move the the double bond towards the plus charge, but not onto the plus charge.
Okay, the bond next to the.
Yeah. So we do have a CH2 here. We know that. So we have to go down here. Just drop it down there. And then where the arrow is ending, it's a double bond.
Okay.
Now, in this case, whatever you do, there's no way you'll satisfy the octet for everything.
Okay. So then.
What you're looking for here is just the stability of carbocations.
So
Because,
the black one because that's secondary.
correct, secondary allylic. This is based off a different chapter we know. We're just going to use here carbocation. So secondary carbocation
Okay.
is more stable. So the resonance will lean more towards the secondary carbocation.
Okay.
Yep. There's no other resonance. If I push this back, it's gonna take me back to the black. That's how I know I don't need to keep drawing.
Got it. Okay.
This one is, how would you draw the resonance here? This is case C in blue. Where should the arrow start, if anything?
On the lone pairs?
No, because if you do that, you'll violate the octet rule.
Pushes towards the most. So you would.
Well, even the other one is gonna violate it, but still, you don't want to move the lone pair on the nitrogen. Never move the lone pair on nitrogen that has a double bond. Never.
Okay. So we would move the double bond.
Towards the nitrogen. Remember
Yes.
how I did this and I did that, and then I say this is positive, this is negative. Still, we are going to violate the octet rule, but it's better than moving the lone pair.
So, you sorry, I'm like trying to formulate. So you never move the lone pairs on the nitrogen only when there's a double bond, or like always with the nitrogen?
You can move it from the nitrogen, but you don't want to do that when the nitrogen already has a double bond.
Okay, got it.
Yeah. That's just an implied and spoken general rule for resonances.
Okay. Okay.
Now, if I had this,
Hold on.
if this is what I had and I have a lone pair,
Mhm.
the double is not there. I'll go ahead and do my resonance.
Okay, and that's A. That was like okay.
Yeah, that is like our A.
Okay.
That's fine. But in this case, if I try to move it, see what happens.
Yeah, you had a triple bond for no reason, and then it's
I
even
get a
more.
triple bond and I have, this is gonna have 10 electrons. By the way, it's better to have less than more
Okay.
octet. You don't want to get more than an octet for an element like carbon. That can happen with sulfur. I think phosphorus can take 12, sulfur can take 12, xenon, iodine, but not carbon.
Okay.
Very few elements can take more than an octet.
Got it. Definitely need to work on resonance. Like,
Yeah, but
there's
you
just
can see it's very doable.
yeah. Okay. Should I screen share one more?
Yeah, let me
We have
share.
time. Um.
Don't know where I
Oh, here
was.
comes a beautiful email from my orgo professor.
Again,
Yeah.
he's trying to justify himself.
I guess. I guess he's finally telling the whole class like how much our exam is worth a week before.
Also, the reply was just to you.
The reply was just to my friend, and then she sent it to me.
Oh, okay,
So
okay.
I didn't even find out. But if I didn't watch the lecture, nobody would have found out because I was the one who like heard him say it. You know what I mean?
Yeah.
I had to become a detective.
CIA. But you see, after the exam, students will be looking at their final grade and they're like, wait, the math is not mathing.
Yeah,
What did
like
he do?
imagine.
Yeah.
That's insane.
Those so still students will be questioning, okay, stop sharing.
Okay.
For me, if you look at my syllabus is like let me give you a sneak peek.
Well, I wish you were my teacher.
I make sure my syllabus is like you have no chance to ask me questions.
That's what I like when professors do that because I don't want to
Yeah.
bother them with silly, stupid questions because I understand they have their own things going on. Also, it's a waste of my time
Yeah.
to, I don't
You
know.
see,
That's
see what I have my learning objectives on there. Even the
uh,
lab I have my learning objectives, and then I break down. Look at the calculation. I break it down. I describe to you how it's broken down, since probably you don't know how to do math. I give the formula in red.
oh, you're great.
Yeah, and then I,
See,
I put it all in a table. If you did not understand the text, you read the table, and then every single day, this is my upcoming class in January. Every single day, I show them what we'll be doing. Every single day, every week, I show everything, and then the exam tells you what chapters.
I'm jealous.
Again, what chapters, exam 2, and then what chapters, exam 3, and here comes the final. I tell them what's required. So for this class, I just need them to do chapter 5 and 6 for the final, and that's it.
I'm jealous. And like,
And
my
then
professor doesn't have like, we don't know how our exams are weighted. He like decides. So if you
he
do really well
decides,
on
like you just told me, he's deciding. And for every single exam, look, I have the key points for them to study. I broke it down. So basically, it's a lot of pages, trust me.
I
Basically,
would
I
read it.
put everything on there imaginable. So by the time you're taking your test, I'm like, it's all in the syllabus. I'm following the syllabus. It's all in the syllabus.
I'm so jealous.
And I don't change it. If I change it, it's for the better of the student.
Yeah.
That's the only time I change it.
I don't think this one is for the betterment of us. Gonna be completely
Uh,
honest,
that
but
that one, oh, no, I can tell you some students, a few students will benefit, those that will score well in final.
yeah, like
Majority will suffer.
if I get an A on this, I'll pass the class with an A. But if I fail it, I'm probably gonna fail the class. Like
That is
I
the
don't.
problem.
I would cry. I spent too much work on this class to not
I
do
know, I can imagine, I can already tell.
that. Thank you.
This is the next one you showed, right?
Yes.
So proton transfer is just transferring a hydrogen, acidic hydrogen goes from one molecule to the other. Write the equation of proton transfer that occurs when each of the following acids reacts with water. So we are starting with H2O, and he is reacting with HBr. Where would you start your arrow?
Oh God.
Okay,
See,
let's take it slow. Who's the acid? Who is the base?
okay. See, we're gonna have to go over this because I don't know this. Like, this is something I always have to spend a lot of time on.
The general you hated?
Yeah, especially Gen Chem 2. That teacher and me did not get along. I did not like
Oh
him.
no. So now let me give you a basic definition. A base usually has an atom which is very electron dense. So he uses the electrons to accept a proton. The acid, on the other hand, is going to have I think we identified partially positive,
Yes, we did
right?
yesterday.
Okay. It's donated. So an acid is just a proton donor.
Okay.
So I can tell because of huge difference in electronegativity, this will be partially positive, more than the one in water, because bromine is more electronegative than oxygen. So this has no choice but to play the role of an acid. This has no choice but to play the role of a base.
Got it.
Your arrow starts on these electrons in the
Okay, so the
base.
arrows on the base. Okay.
Yeah, so we'll start from here and it goes to steal that hydrogen, just like that. That is arrow 1. Arrow
Um,
2, uh-huh.
is the acid always gonna be? No. Yeah, is the acid always gonna be the one that's more electronegative?
The acid is gonna be the one that has a more electronegative element, correct? Or a positive charge. Yes.
Okay.
Remember the area? That's
Like
what
the
you're
item,
looking for. Yeah, aron, resonance, inductive effect, orbital. That's what will tell you which hydrogen is the most acidic. In,
Oh, okay.
in this case, we are using the aron factor but electronegativity because you also have aron and size.
Okay.
So that's
What?
how I decided here. We're going to get H2O plus 4 more charges again, and then Br minus 4 more charges again because the Br has 8 electrons. If you do the 4 more charge of the Br, it will be valency of 7. There's 8 dots, there's no line. Yeah, so that is the mechanism, and it's a proton transfer from the acid to the base.
Okay, so these also need formal charge.
Yes, they do, very much. This becomes a conjugate acid, he has a plus charge. This becomes a conjugate base, he has a negative.
Okay.
Does that make sense?
Yes. Way more sense than what I remembered.
Okay. And you can do the same thing for the sulfuric acid. You decide who's gonna be the acid. Is it water? Because water is amphoteric. Sometimes it's a base, sometimes it's an acid. In this case, the lone pairs are on oxygens. So you can't use the aron factor. What factor would you use? The lone pair is on oxygen. You have HO, HO. So what factor do you use to decide who's the acid?
Okay, so it's atom resonance,
Inductive
induction.
effect, which is electron pull through bond, and orbital, which is hybridization.
And then what's the last one?
Orbital,
Orbital.
which is hybridization. Usually sp is more acidic than sp2, which is more acidic than sp3.
So can you use that one?
Yes, you can use that. And you can use resonance. There are two factors. There's resonance here, making this more acidic.
Okay, so anything that you can use the REO principles on will become the acid.
Yeah, anything that has more of this aerial stuff
Okay.
is gonna be the acid, which is the best shortcut a student can use.
Okay.
And so still this gonna be the base. This gonna be our parent acid. And pushing the arrow, you start from here. You don't need always to write the base as the first molecule.
Okay.
Again, two arrows. The broken bond goes to the oxygen. See how the resonance is gonna come into play. You now have a very electron dense oxygen right there. And those electrons will dance into the sulfur.
Okay.
The water becomes H2O plus. If you want to justify formal charge, be my guest. It will be 6 minus 1, negative 1. And this conjugate base is resonance stabilized. However, because that lone pair is in resonance, these oxygens are sp2. This oxygen right here is sp3.
Okay.
Remember, if a lone pair is in resonance, it's not counted as an electron domain. So
Okay.
you're left with 3 electron domains, 1 lone pair and 2 lines. That makes the oxygen sp2.
Got it. Okay.
All right, so the orbital is sp, sp2, sp3. And we also use, so we use 2 factors. We use the R and O.
Okay.
Here we used the A, electronegativity. Okay, when you're ready, you will tell me about the next one. Who's gonna be the acid? Who's gonna be the base?
Wait, so Adam is like, what is that? Wait, can we just go through the REO stuff one more time? I'm sorry.
Okay. Hey, Rio, don't panic. Don't panic. You got this. Okay, so A is the atom. And the atom, you either going to consider electronegativity if the elements H are in same period of the periodic table.
Okay.
Alternatively, you're going to use size and the A factor if the atom or the atom of the elements with the hydrogen connected to the hydrogen are in same group of the periodic table. Let me give you an example. HI is more acidic than HCl, more acidic than HBr, more acidic than okay, so it's the other way around. I think it's Br before Cl. It's more acidic than HBr, more acidic than HCl, which is more acidic than HF. In this case, water is more acidic than, no, let me start with HF. HF is more acidic than H2O, which is more acidic than more acidic than NH3, which is more acidic than CH4. Why? Here you're looking at an F, you're looking at HF. Someone is sharing material. And then OH, NH, and CH. That's the idea. when you're looking
Okay.
at electronegativity.
Okay.
And this one, by the way, I'm just factoring in acidity.
Got it.
You can use the same ranking to decide basicity.
Okay.
Oh, so resonance is just resonance. I don't know how to describe that.
Yeah.
So increase in resonance equals to increase in acidity, but decrease in basicity. I is inductive effect, which is just electron pull through bond. I'll give you an example. This one is more acidic than this one. Why? The fluorines are pulling electrons through bond.
Okay.
Aerial. This is orbital. You can call it hybridization. Sp is more acidic than sp2. sp2 is more acidic than sp3, which is why when we're talking about amino alkynes, we say that the alkyne is more acidic than the alkyne C hydrogen is more acidic than alkene, and that's more acidic than alkane.
Got it.
Because 50% S character is more than 33%. This S is 33%, and this is sp3, that's 25%. The S orbital is closest to the nucleus. The nucleus is positive. Positive means acidic.
Okay.
That is the crash lesson on that.
Okay.
Now, once you're ready, we come back to C. You can't distract me. You have to answer that question. I was not born yesterday, my friend.
I would say that the acid is the one with the like the one with the positive charge because of resonance.
Yeah, you have resonance and orbital. The main factor in this case will be orbital because this guy is
The double bond.
sp2.
Okay.
Actually, it's sp.
Okay. Oh wait.
No, sp2. We have a lone pair.
Okay.
So it's sp2. But this one right here is sp3.
Got it. Okay. So the water's the base.
Yeah.
So then the arrow starts on the oxygen and water.
But don't go ahead of yourself.
Oh, sorry.
Which hydrogen is more acidic? Because if you're saying this is an acid, you have to decide which hydrogen is more acidic. Is it the CH or the OH?
OH.
Is the OH, you use the A factor,
Yeah.
electronegativity.
Okay. So
So
then
now that you've determined that, now you can tell me how to push your arrow now.
So I would go from the lone pairs on the oxygen of water to the hydrogen attached to the oxygen.
Yes.
And the other thing.
And then you break these to neutralize the plus charge.
Okay.
2 arrows for that. The second
Got it.
arrow ends on the oxygen.
Okay.
Yeah. And now the oxygen will have 2 lone pairs. The water,
H3O plus again.
H2O plus with the black hydrogen added, you're left with only 1 lone pair.
And then the H3O plus is the conjugate acid.
Yes.
And then the other one's conjugate base.
Yes. He can take back the hydrogen going backwards. Okay. Actually, this one should be an equilibrium. Because that acid is a weak acid. The acetone nail polish remover acid, the original acid, is a weak acid.
Oh, which one is that? The double bonded oxygen to the
Yeah,
H.
this one is a weaker acid compared to the conjugate acid.
HCl plus is a really strong acid, right?
Yeah,
Okay. Do I need to like memorize that table?
the pKa.
Yeah. We've never
It
used
depends. It
it.
depends on your. For me, I give my students pKa tables, but when it comes to biochemistry, I used not to give them. I stopped
Okay.
teaching biochemistry.
Okay.
Uh, Biochemistry, you'll be expected to memorize the table, unfortunately, because of the 20 amino acids. But in organic, a good organic professor should provide a pKa chart.
We don't get
Well,
it. Are we surprised? I'm
no,
just, I like
given that
professors.
now your test is at 3%, there's a reason.
Yeah.
It must be probably your class has a very high average or what? Because I don't know why he's
No,
saying it's easier for him in grading.
I
How many
think
exams did
because
you do so far?
five. We've taken five
Why,
exams. I know.
why would
And
you want to double though?
I have no I think because our first two exams are half exams, but they were full exams. Like it wasn't like it was like a quiz. Like they were the same length, same everything. He just like weights them half. So maybe it's because
Okay,
of
so
that,
he
because
weighted
it's
them
still four exams.
halfway. Now he wants to compensate for that.
Yeah, but it's still four exams total then. Like weight wise to be
No,
full.
I
It's
give
just
three
a lot.
exam and a final. I
Yeah,
don't have
I'm
time
dying
for
over
more than
here.
that.
This is way too much.
Yeah, so I don't know why it's doubling. That will now technically be 6.
That's way too much. I'm scared. I'm really, really scared.
Okay, try to normalize your your heartbeat and just pretend you're studying for the other one, the one that was lesser.
Yeah.
So your
Well,
brain will be relaxed to absorb more.
yeah, I wish I didn't know that it was worth that much because I was like so confident like 20 minutes ago and then
Yeah, because it's
but
cumulative anyway. It's just now that you really want to make sure you're doing it right because it's
yeah.
double. Yeah.
And I've worked so hard, so it's like I can't do bad on it.
Yeah. Okay. Did you have another one?
Should we call it a night now?